Hello, welcome to the first lecture of engineering mechanics. Today we are going to study about engineering mechanics and its topics from that point of view. So we will start our subject from its basic definition. Engineering mechanics is the study of motion of rigid bodies under the action of forces. In this subject, we will come across the two different situations of the body, that whether it can be at rest or it will be in motion. So it has two parts, statics and next is dynamics. In static, we will study three topics: equilibrium, plane stresses, principle of virtual work done. In dynamic, we will study about rectilinear and translation, then friction, then circular motion, curvilinear motion, rotary motion, general motion, and work energy theorem. So first we take the definition of force. To define a force, we should consider the three parameters. That is, first one is magnitude, second is magnitude, second is direction, and third one is point of application. Magnitude represents the intensity of the force, that is, how powerful is the force. Direction represents in which direction it is acting, upward, downward, likewise. And point of application shows its its uh, its point where it acts. So all the three parameters are very important, because if any of these parameters is changed, the effect of the force will also be changed. For example, suppose we take a beam, it is a beam and it is hinged at here, some position. Now the force F is equal to say 5 Newton is acting downward at the end point. Also, in next situation, this force F can act at, at this point with the same intensity and in same direction. So effect of this force is to rotate the beam, but effect of this force, it cannot rotate the beam. So so every so every parameter is very important to decide what will be the effect of the force. Next, we talk about the types of forces. In general, we have four types. That is, first one is gravity, Second one is contact force. Third is tension, and fourth one is spring force. Gravity means weight. Contact force, when two bodies come in contact, the normal reaction will produce normal reaction, and also friction will produce. We will talk about tension in rope, belt, chains. These are all are the flexible members. And a spring, it is defined Fs equal to K into X, where K is fixed for a spring, and K is the spring constant, and X is the elongation of the spring. Next we will move toward the next topic, Newton first law. Everyone knows the statement, but we will define it by mathematical way. For particle, first we define the first law for particle, and then we will define it for rigid body. Suppose it is a particle here. So if summation of force equal to 0, then acceleration of particle will also be 0. And for rigid body, if summation of all the forces will be 0, then acceleration center of mass of the rigid body will be 0. We take the case 1 here. Suppose there is a rope and a mass is hanging on it, and it is at rest. So summation of forces is 0, and also acceleration will also be 0. Then tension will be produced here, and mass of the body will act downward. So T equals to mg. Now consider the case number 2. Suppose a surface and a body is at static condition. Static means there is no motion, so there is no acceleration. So center of mass of the body is having 0 acceleration. Also summation of internal forces will be 0. Therefore the mass of body will act downward, and the reaction of the body will be upward. So n minus mg equal to 0, n equals to mg. Next we move toward the Newton third law. It says that to every action there is an opposite and equal reaction which act on two different bodies, collinear in action and same in nature. So the two forces should be collinear. So can the equal and opposite reaction will be there. Suppose a body A and there is a body B. Suppose body A exert a force of FAB on the body B in the horizontal direction. Also the body B will exert the same force with the same intensity but in opposite direction, FBA, on the body A. So we can write it as F of AB will be equal to minus of F of BA. It is the action. Action will give reaction. If FBA is action, then A body will give reaction. Now very important term, free body diagram. It is defined as representation of all the forces acting on the system by the surrounding. Let us take an example. Let us take the same example. There is a rope and there is a mass M. There are two members. First one is rope and next one is mass. If we draw the FBD of mass M, so we will have to separate the mass M from the surrounding. So first draw the mass M. Now what are the external forces acting on it? So first one is its weight, now going downward, mg, and the tension will be also there. So tension, and no other forces is acting on it, so it is in equilibrium. So then T equals to mg. Next we talk about the equilibrium. It is our first topic in static. There are two conditions for equilibrium. First one is summation of all the forces will be 0, or we can say that summation of f of x equals to summation of f of y equal to summation of f of z will also be 0. In x direction, all the forces, net resultant of forces will be 0. In y direction, net resultant will be 0, and in same z there will be 0. Next is summation of torque about any point will be 0. About any point or line in space should be 0. Then we can say that a body is in equilibrium. We take an example by solving question. Let us take an example. Suppose there is a wall. It is a horizontal surface and a ladder is lying inclined, making an angle theta with the vertical. We have to calculate what amount of force P should act here so that the ladder will be in equilibrium. Also the weight of the ladder is W. length of the ladder is L, this is L by 2, this is L by 2. So we have to calculate the P. First, there is a contact between the ladder and the wall, so there is a normal reaction N A. Let us take A B N A. Also there is a N B. Now it is in equilibrium, therefore summation of f of x equal to 0. So N A equals to P and N B equals to W. So we get the two equation. Now we apply the second condition, that is summation of torque or summation of moment about any point will be 0. So we take this point B, summation of moment at B should be 0. This is theta, this is L, then it will be L cos theta and it is L sin theta. Also NA into L cos theta, this is NB. The moment due to this will be 0 because it is acting on the same point, so it can be neglected. Next one is W. So minus W into L sin theta by 2 should be 0. LL cancel. NA equals to W sin theta by 2 into cos theta, that is W by 2 tan theta. So we get the value of P, W by 2 tan theta. Next topic is we take the special cases of equilibrium. There are two special cases. Two special cases of equilibrium. Case 1. Two-force system. Suppose there is a body. Now the force P is acting on the body. We can say that the body will be in equilibrium by applying a force which is acting in the same in the opposite direction, but in the same line of action. With the same intensity, so that the body will be in equilibrium. The first condition is satisfied, is summation of force equal to 0, and next one is summation of moment will also be 0. We can conclude that with the statement, that is, keep two forces in equilibrium, they must be equal in magnitude opposite in direction, and collinear in action. Now case number 2. Three-force system. To keep the three force in equilibrium, to keep the three force in equilibrium, they should be coplanar and acting on same point. Or we can say that concurrent. Suppose the force is P here and Q here. Next one, R. R should be such a way that it is making a triangle, so that net resultant will be 0. Let us take an example. Suppose it is a body in horizontal plane. P force is acting like that, Q force is acting like that. The R force should be here, so that it cancel out the resultant of P and Q, and on the same point all the three forces should act. Then only the body will be in equilibrium.